Alright, this is going to be working on writing formulas for compounds with multivalent cations. Let's first just look at what we're going to talk about here is in the periodic table. We're going to talk about how to name and write formulas with the transition metals or elements with multivalent cations. Okay, multivalent just means it has multiple oxidation states, and these are mostly our transition metals here. So we're dealing with all these elements in here, and then actually we are dealing with these elements right in here. These can have multiple oxidation states. So when you're naming these compounds with these elements in it, you have to tell the person or inform them in the name what is the oxidation state. Okay? And then when you're writing formulas, you have to be told what oxidation state are you looking at. So how do we do that? There's two ways to do it. We can do what's called the stock or the common. The stock is easier. It's basically using a Roman numeral to dictate or to inform the oxidation state. So Roman numeral 1 for gold, gold plus 1. Gold, Roman numeral 3, gold plus 3. Cobalt plus Roman numeral 2 plus 2, 3, so on and on. Very easy for the stock. The common is using a Latin suffix OUS and IC. And then what I say is, so you need to know that auric, AU, is gold. And then you look at gold on the periodic table and you say +1 or +3. Well, if it says Aurus, it's going to be the lower. So I always say O is low. O be low, and the I ending, ic, I be high. So if it's auric, you say, oh, is it +1 or +3? Well, it's the I be high. It's the higher of the one. Aurus, O be low, it's lower. Let's look down here. Ferrous. Ferrous can be +2 or +3. O be low, so it's the +2. Ferric, I be high, so it'd be the higher of the one. Alright, so let's go and let's look at writing formulas. So first of all, what you need to note that, okay, look at this formula and you need to kind of think, first of all, is it an ionic? Yes, it's an ionic. It's a metal and a non-metal, so it is an ionic. Is it a polyatomic or binary? IDE. IDE tells me it's a binary. Okay. All right. And then, do I have a transition metal or multiple oxidation states? And it's an ic. I do. I do. So, just start off. Let's say ferric is iron. There you go. Fe. Ferric. I be high. So is it +2 or +3? It's +3. I be high. It's the higher of the one. Oxide. Oxygen is oxygen with a -2, and then you just crisscross. And make sure you don't have your charges down here, Fe2O3. Okay, and again, ites and eights. If it's ite and 8, it's going to be a polyatomic. So here we go for cobaltic. So cobaltic is CO. Cobaltic could be a +2, +3. Which one is it? I be high, so it's the +3. And then phosphate, ATE, tells me that it's a polyatomic. And that's a -3. So I would crisscross my 3's here, and basically I can reduce to be this, to have one cobalt and one phosphate will neutralize out. Alright, so let's just do a couple here. So cuprous is copper, and again, the lists are on the back of your the divalent cation are on the back. Copper +1 or +2, O be low, +1. Chloride, IDE, tells me it's Cl -1. At a 1-to-1 ratio, those neutralize out. Ferrous is iron. Iron can be a +2 or +3. O be low, so it's going to be a +2. Oxide, IDE, tells me it's oxygen. Okay, crisscross those, and again, at a 1-to-1 ratio, these will cancel out the 2's down here. So we go FeO. Aurus is AU, or gold could be a +1 or +3. O be low. Okay, and then citrate, ATE, tells me that it's a polyatomic, so I need to look on my polyatomic sheet. And citrate is alright, we're going to crisscross 3 to 1. There's going to be 3 golds to neutralize out this. Cupric, copper, which one is it? +1 or +2? I be high. And then amide Now, even though this is tricky, and this one I'm not going to test you on, but amide is actually is a polyatomic. Even though it does have an IDE ending. Ferret, iron, +2 or +3, O below, so it's +2. Sulfate, you need to know, sulfate, -2. At a 1-to-1 ratio, the +2 and the -2 will cancel out. And there you go for that one. All right, let's look at the stock system. The stock system is very easy, and this is the one that's actually mostly on the SOL. Copper 2 chloride. Copper 2 +2 chloride IDE. So it's just chlorine, crisscross, and there you go. So we're going to go iron. Do it down here so you can see. Iron, Fe. What's the oxidation state? It says Roman numeral 3, so +3. The biggest thing is a lot of kids want to say, oh, Roman numeral 3 is 3 atoms of iron. No, it does not. It's the oxidation state. Citrate is ATE, and that's going to be C6H5O7, the -3 charge. And again, we would crisscross the 3 and the 3, and those will cancel out. Remember, you cannot change anything inside the parentheses. Those are protected. You can't change the citrate formula. So it's going to be C6H5O7. At a 1-to-1 ratio of this to this, they neutralize out. All right, let's take a couple of these and practice. All right, so it says lead. Lead is Pb. Lead's one of those ones that is not actually a transition element, but it does have multiple oxidation states. So lead can be +2 or +4. Which one is it? Roman numeral 4 or +4. Bromide, IDE, -1. So we're going to crisscross PbBr4. Tin, Sn. +2 is the oxidation state. How do I know that? Because it says Roman numeral true. Nitrate, NO3 with a -1 charge. That's one of the ones you need to memorize. Sn, NO3, 2 of those. Chromium, Cr. Chromium can be a +2, +3, +6. Which one is it? +3. Acetate, ATE. C2H3O2 with a -1. Crisscross the 1 and the 3. So we have Cr C2H3O2. Taken 3 times. Chromium 3 again. Oxide, IDE, -2. So that's going to be crisscross. Okay, and there's that. Let's see which ones. Okay. Let's do a couple more here. Now with this one, it says hydrogen sulfate. Sulfate, you should know, is an SO4 with a -2 charge. However, it says hydrogen, so we're going to add a positive hydrogen in there. And that's going to make this whole thing. If we add a positive to this -2, that's actually going to make it into a -1. -2 plus 1 equals -1. So the 1's going to go here, the 3 goes outside there. and then we can erase our charges. And there we go, and we don't really need the 1. Try some of these over here. Okay, Cuprous. Cuprous, O below, so is it +1 or +2? +1, hydroxide, OH, -1. At a 1-to-1 ratio, those neutralize out, so CuOH. Cupric. Again, transition metal, so you need to think, hey, it's +1, +2. Which one is it? IB high, +2. Bicarbonate is CO3 with a -2 charge. The bi actually means hydrogen, so we're going to add a +1 in there. So if this is a -2 and this is a +1, the whole thing has a -1 charge. So 1 goes here and the 2 goes there. Okay, calcium chlorate. Okay, the 1's going to go here, and the 2's going to go here. So we're going to have CaClO3, 2. Zinc can only be a +2. The only one. Again, if you need help to know, do I use Roman numerals, or do I need to, do I have multiple oxidations? Just look at the periodic table. Sulfite is SO3 with a -2 charge, and with a 1-to-1 +2 -2, those actually just neutralize each other out. So there's the answer there. Okay, that should get us through. Let's do a couple more here. See what our timing is. That should be enough. The next lecture will be the part 3.